Picture this scene: the winter of 1915, the Winter Palace, the study of Russian Emperor Nicholas II. Outside the windows a blizzard raged, while on the fronts of the First World War, thousands of Russian soldiers perished, bogged down in endless attacks on fortified enemy positions. The front line had frozen, transforming into a continuous system of trenches, barbed wire, and machine gun nests. Generals racked their brains trying to figure out how to break through this dead zone where any attack turned into a slaughter. And at this very moment, a little-known engineer named Nikolai Lebedenko requested an audience with the sovereign, promising to demonstrate something capable of changing the course of the war. The Tsar agreed to the meeting, expecting to see yet another set of blueprints or calculations, but what happened next surpassed all expectations. Lebedenko took a small wind-up toy from his pocket and placed it on the floor of the imperial study. He turned the key, then released it, and the tiny model, with two enormous wheels on its sides and a small one at the back, began to roll briskly across the parquet floor, easily overcoming obstacles. Nicholas II, ruler of the world's greatest empire, literally knelt down beside the engineer, and the two of them began to play with this mechanical toy like schoolboys. Lebedenko hastily constructed improvised barricades from stacks of books representing trenches and trenches. The wind-up model easily clambered over them. Its enormous wheels simply rolled over the obstacle, while the small rear wheel dutifully followed behind them. The sovereign watched this with genuine delight. His eyes glowed with enthusiasm. He saw not just a toy, he saw salvation for his army. He saw a machine that could breach any defense, crush barbed wire, cross over trenches, and deliver machine guns directly into the enemy's rear. Lebedenko explained his idea to the emperor. Enormous wheels, with a diameter several times greater than a man's height, would allow the machine to overcome any obstacles encountered on the battlefield. Shell craters, ditches, embankments, fallen trees, all would prove powerless before the cyclopean dimensions of his creation. The meeting lasted for more than 1 hour, and by its end, Nicholas II was fully convinced of the project's genius. He granted Lebedenko personal imperial authorization for the construction of the war machine and allocated a truly fantastic sum for the time from his personal funds, approximately 210,000 gold rubles. For comparison, with this money, one could have built several medium-sized factories or purchased an entire fleet of automobiles. But the Tsar was not stingy. He believed that this machine would turn the tide of the war in Russia's favor. Lebedenko left the palace elated, clutching in his hands a document bearing the imperial seal, which opened all doors for him and granted unlimited access to the empire's resources. The very next day, he began work on realizing his dream. And this work became shrouded in a level of secrecy unknown to any other military project in Russia. The project received the code name Nitopir, and a system of conspiracy was built around it, worthy of the most classified developments. Lebedenko perfectly understood that if information about his machine leaked to the enemy, the element of surprise would be lost and the idea itself could be copied. Therefore, he made a brilliant decision. Not a single factory was to know exactly what it was producing. Hundreds of individual parts are broken down from the blueprints, each of which is ordered from different enterprises throughout the Russian Empire. Some factories are told they are manufacturing parts for a new warship, others that these are components for industrial equipment at metallurgical plants, and still others that they are structural elements for railway bridges. Huge steel discs for the wheels are produced at the Putilov factory in Petrograd, disguised as flywheels for turbines. The spokes for these wheels are ordered from a completely different enterprise, described as beams for building structures. Shafts and axles are manufactured at a third factory, ostensibly for ship mechanisms. Lebedenko brings two talented engineers to the project: Nikolai Zhukovsky, who was already a recognized specialist in aerodynamics at that time, and Alexander Mikulin, a young but promising designer. Zhukovsky takes charge of structural strength calculations and load distribution, while Mikulin handles the power plant. And here an interesting problem arises: where to find engines powerful enough to set in motion a machine weighing several tens of tons. Ordinary automobile engines of that era produced at most 20 to 30 horsepower. This is catastrophically insufficient. Ship engines are too large and heavy. And then a brilliant idea comes to Mikulin: to use aircraft engines from German Zeppelin airships. These engines are powerful enough, each delivering 240 horsepower, while being relatively light and compact. Fortunately, Russian aviation and anti-aircraft artillery managed to shoot down several German airships, and their engines, practically undamaged in the fall, are stored in military warehouses. In the spring of 1915, the most complex part of the work begins: the assembly of the machine. For this, a remote location is chosen, far from large cities and railways, the vicinity of the village of Orudyevo in the Dmitrovsky Uyezd of Moscow Governorate. Here, amidst forests and fields, away from prying eyes, a true construction of the century unfolds. Hundreds of workers bring parts here from all over Russia, not even suspecting what exactly they are assembling. The territory is fenced off with a high barrier, and military guards are posted. No outsiders are allowed even close. Local residents are told that a secret military warehouse or an artillery testing ground is being built here. The parts begin to connect into a single whole, and gradually, from a pile of metal, something entirely fantastic emerges. A machine unlike anything the world has ever seen. Two giant wheels, each 9 meters in diameter, with spokes as thick as a human arm, rise above the ground like two towers. Between them, at a height, is situated a T-shaped hull, 12 meters wide, inside which the crew, engines, and transmission are housed. The design strikes the imagination with its dimensions. If an ordinary person were placed next to the Tsar Tank, they would appear like an ant. The machine's height at its highest point reaches 9 meters, which is like a 3-story house. The hull's width exceeds the dimensions of an entire railway car, and the weight of the entire structure approaches 40 tons, comparable to a small locomotive. Machine gun emplacements are installed on the hull, providing all-round fire. Lebedenko designed the weapon system so that the machine could fire in all directions simultaneously. Machine guns are located on the upper turret for firing at ground targets and at the enemy situated on elevated positions. Embrasures are installed on the sides of the hull for firing to the side and to the rear. Even the lower part of the machine is protected. Loophole embrasures are provided there for shelling the space directly beneath the tank, so that enemy infantry could not get close and plant explosives. The crew was to consist of between 15 and 18 people: a commander, a driver-mechanic, 2 engine mechanics for engine maintenance, and up to a dozen machine gunners with loaders. For this, work was in full swing. Mikulin was struggling to make 2 captured German engines work synchronously and transmit torque to the enormous wheels. The problem was that each wheel had to be driven by a separate engine, but their speeds had to be perfectly synchronized. Otherwise, the machine would be pulled to one side. To achieve this, a clever system of RPM regulation and a differential gear was devised. Zhukovsky was engaged in calculating the strength of the wheel spokes, as they would have to withstand an immense load when the tank was traversing obstacles. Each spoke was made of high-strength steel and capable of bearing a weight of several tons. Lebedenko personally supervised every stage of assembly, checking every joint, every bolt. He understood that he would have only one chance to prove the viability of his machine, and this chance could not be missed. By the end of the summer of 1915, the Tsar Tank was ready, and the test date was set for August 27th. The morning of August 27th was clear and warm. A special military commission arrived at the test site, consisting of representatives from the Ministry of War, general staff officers, and technical experts from various engineering corps. All of them had received the strictest instructions regarding the non-disclosure of what they witnessed, under threat of military tribunal. When the commission members first saw Nitapir, many simply froze in place with open mouths. Even the most experienced military engineers, who had seen dozens of samples of the latest technology in their careers, could not hide their astonishment. Before them loomed a steel leviathan that resembled a mobile building more than a combat vehicle. One of the generals uttered a phrase that later became legendary among the test participants. "This is either genius or madness, but we will only find that out now." Lebedenko conducted a detailed tour of his brainchild for the commission. He demonstrated how the power plant was designed. 2 Zeppelin engines were located inside the hull with their own set of fuel tanks, a cooling system, and exhaust pipes. The engines were installed in such a way that they could be serviced even while the vehicle was in motion. For this purpose, special walkways and platforms were provided inside the hull. The engineer explained the principle of control. The driver mechanic could regulate the RPM of each engine independently, which allowed the machine to turn by means of the difference in the rotational speeds of the wheels. If the left wheel rotated faster than the right one, the tank turned to the right, and vice versa. To turn on the spot, one engine could even engage reverse, while the second continued to operate in forward gear. Theoretically, this provided the machine with fantastic maneuverability, despite its dimensions. The commission paid special attention to the rear roller, a small wheel with a diameter of only 1.5 meters, which was located in the rear part of the machine. It was intended to ensure the stability of the structure and prevent the rear part of the hull from dragging along the ground. Zhukovsky presented mathematical calculations proving that when moving on solid ground, the load on this roller would be minimal. The main weight of the machine rested on the front wheels, and the rear roller served only for balancing. However, some engineers from the commission were already expressing doubts at that time. What would happen if the ground turned out to be soft? Lebedenko confidently replied that the enormous front wheels created such pressure on the soil that they compacted it, and the rear roller would roll along an already flattened track. Furthermore, the wide contact area of the front wheel with the ground distributed the machine's weight in such a way that the pressure on the ground was even less than that of a conventional truck. The discussions lasted for about 1 hour, but ultimately it was decided to proceed with a practical test. Preparations for the tests were thorough. To begin, it was decided to test the machine on a specially prepared corduroy road, composed of thick logs laid across the direction of movement. Such corduroy roads had long been used in Russia to overcome marshy areas, and the military wanted to ensure that the tank could handle this type of surface. The corduroy road stretched for approximately 50 meters, after which ordinary forest soil with grass and small shrubs began, and further on there was a section of wetter ground at the edge of a small bog. The test plan involved moving along this entire route and then turning around and returning. The crew took their places inside the machine. 2 mechanics positioned themselves near the engines with tools at the ready. Their task was to monitor the operation of the engines and immediately rectify any malfunctions. The driver mechanic settled into his post with the engine speed control levers. The machine gunners took up positions at the embrasures, although no shooting was planned for that day. Their presence was required to check weight distribution with a full crew. The command to start was given. The right engine started first. It sputtered a few times, emitted a cloud of bluish smoke from the exhaust pipe, then hummed smoothly and powerfully. After 1 minute, the left engine joined it. The sound of 2 operating aircraft engines was deafening. The commission members standing nearby instinctively covered their ears with their hands. The mechanic began to smoothly increase the revolutions, and the enormous wheels slowly, as if reluctantly, began to turn. The ground beneath it trembled. The machine moved from its spot, and a triumphant cry erupted from the workers and engineers who had toiled for months on this project. The Tsar Tank was moving. The speed was not high, only several kilometers per hour, but the sheer ability of this steel mountain to move seemed a miracle. The front wheels rolled majestically and relentlessly, their spokes gleaming in the sun. The rear roller obediently followed the machine, leaving a deep furrow in the ground behind it. A young birch tree was intentionally left in the tank's path with the thickness of a human arm, the first obstacle to test its cross-country ability. Lebedenko wanted to demonstrate to the commission that his machine was capable of breaking trees and clearing its own path in the forest. The distance to the birch tree diminished, and then the right front wheel touched the slender trunk. A crunching sound was heard. The tree bent, tried to stand firm, but the multi-ton mass was relentless. The trunk cracked at its base, and the birch tree collapsed, crushed by the wheel. The tank did not even slow down, as if it had not noticed the obstacle. The commission hummed approvingly. The ability to crush trees meant that the machine would be able to clear paths through forest debris, which the enemy often used as barricades. The next stage was movement over the gati. The log flooring creaked under the machine's weight, but held. The wheels rolled from log to log, creating a rhythmic thud. The machine bounced slightly over the uneven surfaces, but maintained stability and continued to move forward. 50 meters on the gati were successfully covered, and it seemed that all doubts had dissipated. Ahead, a section of ordinary grass-covered ground began. The soil here was quite compact, having been tamped down over many years. The wheels bit into the soil, leaving deep ruts behind them, but the tank continued to move confidently. After covering another 20 meters, the machine approached an area where the ground became noticeably more moist. Here, at the edge of the boggy section, the soil was saturated with water. Beneath a thin layer of sod, a viscous mire lay hidden. The military had specially chosen this route to test the tank in conditions as close as possible to a real battlefield. After all, on the front, the machine would have to move over ground churned by shells and softened by rains. The driver mechanic did not reduce speed, confident in Zhukovsky's calculations regarding weight distribution. The front wheels moved onto the soft ground, pressed into it, but continued to rotate, slowly propelling the machine forward. However, what was happening at the rear remained hidden from the crew's eyes. The rear roller, which bore a significant portion of the machine's tail section weight, began to sink into the soft soil, while the front wheels, thanks to their enormous size, distributed the load over a larger area. The small rear roller created critical pressure on the ground. It pressed into the wet earth deeper and deeper, sinking into it like a stone in quicksand. The further the tank advanced, the deeper the roller bogged down. Finally, the moment arrived when the rear part of the hull began to sag, and the roller buried itself in the ground almost up to its axle. The mechanic felt that the machine was moving more heavily. The engines began to work under increased load, and the roar intensified. He increased the revolutions, hoping to pull the tank out of the trap with the power of the motors. The front wheels spun, throwing clumps of mud. The rear roller was hopelessly stuck, and the tail section of the Tsar Tank settled onto the ground, burying itself with its own weight. The engines roared at maximum revolutions. The wheels spun, but the machine did not move either forward or backward. It was stuck fast, like a giant insect caught in amber. The mechanic tried changing the engine revolutions, put it in reverse again, then forward, but there was no result. The behemoth of 40 tons had turned into an immovable monument. Within several minutes, at Lebedenko's command, the engines were shut down to prevent them from overheating needlessly. A silence descended, which proved deafening after the hours-long roar of the aircraft engines. The commission members silently approached the stuck machine, walked around it, looked under its chassis, and saw a dismal picture. The rear roller had sunk almost completely into the ground, and the tank's tail itself rested on the soil, creating additional resistance. One of the engineers performed a quick calculation and announced a disheartening conclusion. To extract the machine from this spot would require efforts that the installed engines could not generate. Either external traction or a complete disassembly of the tank on site would be necessary. Lebedenko was disheartened, but did not give up. He suggested attempting to free the machine with the aid of winches and tractors, placing logs under the roller, and digging a pit in front of it to reduce the chassis' angle of inclination. Attempts at evacuation continued for several days. 2 powerful tractors were brought in, steel cables were stretched, and attempts were made to pull the tank backward onto firmer ground. The cables snapped under the monstrous load. They tried digging under the rear roller to free it, but the pit immediately filled with water, turning into a true bog. Thick logs were placed under the wheels, but they cracked and broke like matchsticks under the machine's weight. All efforts proved futile. The Tsar Tank thus remained stuck at the site of its first and last trial, transformed from a hope of the Russian army into a monument to engineering error. In the following week, Lebedenko, with his team of engineers, attempted to understand precisely where a critical error in their calculations had been made. Shukovsky performed new computations, rechecked old formulas, and constructed load distribution diagrams. The results proved disheartening. Of the machine's total weight of 40 tons, almost half was concentrated in the rear section, where the fuel tanks, part of the ammunition, transmission mechanisms, and the hull itself with its armored turret were located. The front wheels, despite their colossal size, could not compensate for this imbalance when moving over soft ground. Moreover, it became clear that the toy model, which had so delighted the emperor, operated on entirely different physical principles. With its low weight and solid parquet flooring, the problem of the rear wheel sinking simply did not manifest. Scaling the design up by tens of times led to the laws of physics beginning to work against the tank's creators. The military commission prepared a detailed report on the test results. The document acknowledged the originality of the design concept and the high quality of the component's manufacture. However, an unequivocal conclusion was drawn regarding the machine's unsuitability for combat deployment in its current form. Its inability to move over loose ground, which was precisely what predominated on the fronts of the First World War, was particularly criticized. The battlefields were a quagmire of mud, shell craters, and destroyed trenches. It was in such conditions that the tank was supposed to prove its effectiveness, yet it could not even traverse hundreds of meters over relatively favorable terrain. The Commission recommended either completely redesigning the structure or deeming the project a failure and ceasing funding. Lebedenko did not lose hope of rectifying the situation. He proposed increasing the diameter of the rear wheel to 3 or even 4 meters, which was intended to reduce ground pressure. Another option involved installing not one, but two rear wheels side by side to distribute the load. The possibility of creating a third front wheel and transforming the machine into a three-wheeled configuration with two driving wheels at the front and one at the rear in the middle was even considered. Each of these solutions required a serious overhaul of the already built structure and immense additional expenses. McCoolin calculated that the implementation of any option would require at least another half-year of work and funding comparable to what had already been spent. Given the failure of the first trials, finding such money was practically impossible. The situation was complicated by the fact that by the autumn of 1915, Russia's position on the fronts had worsened. German troops were conducting successful offensive operations. The Russian army was retreating, losing territories, and sustaining enormous losses. The country needed weapons immediately, not in half a year or 1 year. The War Ministry shifted its attention to acquiring artillery, rifles, and ammunition, things that could help right away. Experimental projects like the Tsar Tank receded into the background. Furthermore, by this time, information began to reach Russia about the British development of their own tracked armored vehicles. These machines were significantly smaller, lighter, and most importantly, demonstrated good cross-country capability during trials. It became clear that the future lay with tracks, not with gigantic wheels. In winter, funding for the project began to experience interruptions. The money allocated by the Emperor ran out, and no new appropriations were forthcoming. The Guard was removed from the territory where the stuck tank stood, as it was needed at the front. Workers dispersed to their homes or were mobilized into the army. Lebedenko, with a few assistants, continued to visit his brainchild for some time, trying to come up with something, but with each visit it became clearer that the project was dead. The Nitopir remained standing in the forest near the village of Orudievo, slowly becoming overgrown with grass and bushes, transforming from a hope for victory into a rusting monument to unfulfilled ambitions. The year 1917 arrived, bringing Russia upheavals that no one could have even imagined until recently. The February Revolution swept away the monarchy. Nicholas II abdicated the throne, and the country plunged into the chaos of political struggle. In this maelstrom, no one cared about the steel monster stuck in the forest. The provisional government tried to continue the war and simultaneously hold on to power. It had no time for the experimental projects of the former regime, and the Tsar Tank was simply forgotten, as if it had never existed. Project documentation settled in the archives of the War Department. Blueprints gathered dust on shelves, and the machine itself continued to rust under the open sky, hidden from casual eyes by the dense bushes that had grown around it over 2 years. The October Revolution definitively sealed the project's fate. The Bolsheviks who came to power viewed the Tsar Tank solely as a symbol of the Tsarist regime's extravagance and the technical incompetence of old engineers. When in the spring of 1918, representatives of the new government discovered mentions in documents of 210,000 rubles spent on a certain secret combat vehicle, an investigation was organized. The commission traveled to the tank's location, inspected it, and concluded that it was a monument to mismanagement and the incompetence of the imperialist government. The report noted that the money spent on this useless pile of metal could have been used to purchase hundreds of rifles, dozens of machine guns, or several artillery pieces. Lebedenko attempted to prove that the problem was solvable and the machine could be brought to working order, but no one listened to him. The era of colossal projects had passed. The country required simple and reliable solutions. The Civil War began, and the tank was once again forgotten. The fronts were far from Dmitrovsky Uyezd, and hostilities bypassed this quiet corner. Local residents occasionally visited the strange structure, children played around the enormous wheels, and adults marveled at the size of the construction, wondering what purpose it could possibly serve. Some particularly enterprising peasants attempted to unscrew bolts and carry away small parts for household needs, but the main structure remained untouched. It was impossible to dismantle such a behemoth without special equipment. Gradually, the Tsar Tank transformed into a part of the landscape, a local landmark about which visitors were told as a curiosity from the old regime. In the early 1920s, when the Civil War concluded with the Bolshevik victory, the new government seriously undertook an inventory of military assets. There was a need to restore ruined industry, the army, and infrastructure. Metal was in short supply. It was catastrophically scarce. Someone remembered a steel structure weighing 4 dozen tons, standing idle in the Moscow region. A decision was made to dismantle the Tsar Tank for scrap metal and use the steel for the needs of the national economy. In the summer of 1923, a team of workers arrived in the village of Orodievo with gas cutters and lifting mechanisms. The dismantling work took several weeks. The enormous wheels were cut into segments, the hull was sawn into parts, and all of it was loaded onto trucks and taken for smelting. By autumn, at the site where the Natapier had stood for 8 years, only deep ruts from the wheels remained, leading to the crater where the rear roller had become bogged down. Thus ingloriously ended the history of the largest combat vehicle ever constructed in metal. The project, which began with a child's toy in the hands of an emperor, concluded as a pile of scrap metal in a factory yard. From 4 dozen tons of high-quality steel, parts were cast for tractors, machine tools, and locomotives, things that the country truly needed. The blueprints of the Tsar Tank lay in archives until the late 1930s, when a historian of technology stumbled upon them by chance and published an article about this astonishing project. Since then, Lebedenko's Tsar Tank became a legend, a story of how a seemingly brilliant idea can fail due to a single critical error in calculations. Decades after the disappearance of the Tsar Tank, military historians and engineers continued to debate the reasons for its failure. The main mistake was evidently the catastrophically incorrect weight distribution between the front and rear parts of the machine. Almost 20 tons out of 40 were concentrated in the tail, making the small rear roller a critical point of failure for the entire structure. Yet, the very idea of large wheels for overcoming obstacles was not absurd. Its implementation simply proved incorrect. Interestingly, British designers, who created their first tanks around the same years, also experimented with size. Their machines featured tracks encompassing the hull along its perimeter, which provided an enormous contact area and excellent cross-country capability. Lebedenko was a talented inventor, but he lacked experience in creating heavy combat vehicles. His confidence in success was based on the performance of a toy model that functioned perfectly in miniature. However, the laws of mechanics operate entirely differently when mass is increased 1,000-fold. The ground pressure increases disproportionately, the material resistance changes, and what worked for a model weighing several hundred grams proved inapplicable to a 40-ton behemoth. Zhukovsky, a great scientist and the founder of aerodynamics, did not specialize in ground vehicles. Therefore, his calculations, though mathematically sound, did not account for all the practical nuances of movement over soft ground. Curiously, the idea of giant-wheeled combat vehicles periodically emerged in various countries. In Germany, towards the end of the First World War, projects were considered for vehicles with wheels up to 15 meters in diameter. Americans in the 1920s experimented with enormous wheeled tractors for agriculture. However, all these projects remained on paper or as small models because engineers learned a lesson from the Russian experience. Tracked locomotion proved to be the only working solution for heavy machinery, and it became the standard for world tank building for the next 100 years. The Tsar Tank of Lebedenko forever remained in history as the largest wheeled combat vehicle actually built and tested. Neither before nor after it did anyone create anything similar in scale and ambition of design. It was a unique engineering experiment that showed the limits of the possible and proved that in technology, more does not always mean better. Today, nothing remains of the Netapir except yellowed blueprints in archives and several photographs taken during testing. But its memory lives on as a reminder of a time when engineers were not afraid to think big and attempted to create the impossible. If you like this story about an astonishing machine that could have changed the course of war but ultimately failed to move, please like this video. Write in the comments what other unusual examples of military equipment you would like to see on the channel. Subscribe so you do not miss new stories about humanity's strangest inventions. Thank you for watching.